Did you know that AI systems can sometimes be biased, reflecting the prejudices present in their training data? Are you aware of the privacy implications when sensitive healthcare data is used to train AI models? In this module, we explore two important challenges of using AI bias and privacy concerns. By the end of the module, you will be able to define AI bias, discuss the reasons for AI bias, identify ways to mitigate AI bias, and summarize AI-related privacy concerns. AI bias. AI bias refers to systematic errors in the output of AI algorithms that stem from assumptions in the machine learning process. This can result in unfair or prejudiced outcomes that can disproportionately affect certain groups of individuals or skew data interpretations. Bias in AI can harm people. AI tools can make decisions that affect whether a person is admitted into a university, gets a bank loan, or gets a life-saving medical procedure. Here are some other examples of AI bias. Making hiring recommendations based on a person's name or gender. Predicting criminal behavior based on neighborhoods. Predicting recidivism for certain crimes. Recommending some medical devices to certain patients. Chatbots sharing inappropriate and inaccurate personalized recommendations. Recognizing only individuals with lighter skin tones from images. And misidentifying or excluding certain individuals for a medical procedure. I love this quote by Reva Schwartz, where she says, "Context is everything. AI systems do not operate in isolation. They help people make decisions that directly affect other people's lives. If we are to develop trustworthy AI systems, we need to consider all the factors that can chip away at the public's trust in AI. Many of these factors go beyond the technology itself to the impacts of the technology." The causes of AI bias include data bias, algorithm bias, confirmation bias, human bias, and systemic bias. Data bias. If the data used to train the AI system is biased, the output will also be biased. This often happens when the data used to train the model is not representative of all groups it will affect. Was the system trained on data from males, females, or both? Was the system trained on data from different racial or ethnic groups? Algorithm bias. This occurs when the rules and algorithms used to process and interpret data introduce bias. If an algorithm is designed to prioritize or weigh certain types of data over others, it could lead to biased outcomes. Confirmation bias. AI systems learn from feedback. So if the system receives biased feedback, they can incorporate and amplify these biases. Human bias. Human bias in AI systems stems from problems introduced by the individuals who design and train the machine learning systems. These people could either create algorithms that reflect unintended cognitive biases or real-life prejudices. Systemic bias. AI systems can perpetuate systemic bias. For example, AI systems used to evaluate potential rental tenants rely on court records and other data sets. These data sets have their own built-in biases that reflect systemic racism, sexism, and ableism, and are notoriously full of errors. How to mitigate AI bias? To mitigate AI bias, it's essential to use diverse, representative data to train AI models and to regularly test AI systems for bias and fairness. A diverse group of individuals should be involved in the development, beta testing, and evaluation of the system to help recognize and counter potential bias. AI privacy concerns. AI privacy concerns include data collection, data sharing, inferential privacy, and data security. With data collection, AI systems rely on large amounts of data from a variety of sources to operate effectively. This can include personal and sensitive data from electronic medical records or user behavior from social media. Data sharing. Data used in AI systems are often shared with multiple entities, including AI developers, third-party vendors, and researchers. This increases the risk of privacy breaches. Inferential privacy. AI algorithms can use data to make inferences about individuals, such as predicting their behavior, preferences, or health status. These inferences can reveal sensitive information that individuals might not have chosen to disclose. Data security. AI systems that store large amounts of data can be attractive targets for cyber attacks, which can lead to privacy breaches. Let's look at privacy issues in daily life. AI systems are increasingly used in many aspects of daily life, from social media algorithm to smart home devices, mobile phones, smartwatches, and other digital devices. These systems collect a lot of data, including browsing history and location data, which can infringe on individual privacy. Privacy issues in healthcare. AI systems often use sensitive health data to predict diseases, recommend treatments, or manage patient care. While these applications may improve health outcomes, they also raise privacy concerns. For instance, wearable health devices can continuously collect personal health data, raising questions about who has access to this data and how it's shared. Privacy issues in research. AI systems can analyze large data sets to find patterns and correlations that might not be apparent to human researchers. While this can lead to significant scientific advancements, it also raises privacy concerns. For example, AI can sometimes de-anonymize data, thus identifying individuals based on patterns in the data. In summary, there's excitement about the enormous potential of AI systems. In this module, we learned about the need to ensure that these systems minimize bias and respect privacy rights. Ultimately, the responsibility for addressing and preventing bias and protecting privacy lies both with those people who develop and use the technology.